Now, before we start with the forward pass and feed our image to the first convolution, meaning right here, I want to take a moment and do a quick overview of image filtering. So we're going to open our Colab notebook. We can visualize our table of contents here. And in particular, we're going to go all the way down to input image to neural net. So here, what we're going to do is load our image, im.pt, into our Colab. im.pt is X, which is the input to our neural network. So we're going to download it from this URL and save it to the files folder. YOLOv5, files, right now it's empty. Okay, so we're going to run this. As usual, the first thing that we have to do is mount our Google Drive. So let's click connect to Google Drive, select our Google account, and then continue and continue until it's mounted. Okay, so our drive has been mounted, and we now have the file, if I refresh, of im.pt right here. The next thing that we're going to do is load that file and then show it here with imShowTensor. Now, given that this is a repetitive operation, I've created these helper functions here at the top so that we can just call these functions over and over as we go through our Colab instead of writing the steps every time. So let me show you. Now here in the helper functions section, I've created some functions. There is no need to understand these functions below, and that is why I hid them here. They're mostly boilerplate code and some repetitive functions that we're just going to call through our notebook, and we don't need to understand them perfectly. In fact, most of them were actually generated directly from ChatGPT, as you'll see later with some of the plot functions. In particular, we're calling the imShowTensor, and then we're basically removing the batch dimension, changing the order of the indexes, multiplying by 255 to 8-bit depth or unsigned integer 8, and then using matplotlib to display it. There are other functions here as well, and most of them are actually plotting functions that we'll use later. So what we're going to do is just hide these and then run it, and then come back to our input image to neural net, and now we can actually run this cell right here. And this is nothing new, just doing a quick recap of our input image to the neural net, which has 1 by 3 by 640 by 640 dimensions, the batch, the channels, the height, and the width. So with that, let's go ahead and jump to the convolutional section. And in particular, we're going to focus on the image filtering first. So in image processing, a kernel or convolution matrix is a small matrix used for blurring, sharpening, embossing, edge detection, and more. This is accomplished by doing a convolution between the kernel and the image, as we'll see in much more detail. In this page, we can actually see some of the most common edge detection kernels. So if I go here, and in particular, we're going to focus on these ones here, the pre-width operator in both the horizontal dimension as well as on the vertical dimension. Remember, the image is X to the right and Y top down. We're going to look at the Sobel operator as well as the Laplacian and a few other. If you see this 3x3 kernel, you notice that there's negative on the left, 0, and positive on the right. And then similar pattern, but for the height. And then the Sobel operator, it's an edge detector that puts more emphasis on the center receptive field of the kernel. And then similarly for the height, and then the Laplacian has this 3x3 kernel. So let's jump to our Colab environment. So I've defined a dictionary with all these different kernels or filters, but I've also added a Gaussian filter, which is also a smoothing filter, and then also an emboss filter, as you'll see in just a moment. So what we're going to do is run this cell, and we're going to feed our input image, X, from right here. And we're going to perform image filtering using these different filters on that input image. For this example here, we're just showing a stride of 1 and pattern of 1. We'll go into what these two are in much more detail later in this video. And we're also using this function that was also created within the helper functions section. So let's go ahead and run this. And if we scroll here to the bottom, you can actually see the different filters. So this is pre-width horizontal, meaning that edges will be enhanced or will be sharpened. So the filter goes in this way across the image. But basically, you can see that pre-width horizontal and pre-width vertical show different results, enhancing different features or different edges within the image. You can also see that we have red, green, and blue channel. For this filter, it's difficult to see the difference. But if you pay close attention, for example, here, you can actually notice that the resulted image, the convoluted image, is different for different channels. In this case, we've used the same filter. Each of these filters have been used for every channel within the image. Although in practice, you'll probably have one filter dedicated for every channel, as we'll see shortly as well. If we continue looking at the other filters, for example, if we compare these two, you can see that the Sobel operator, Sobel filter, gives you a different type of image. And then the Laplacian operator, also an even different image. Again, these are different filters that, when applied to an image, enhance different features, different aspects of the image. And in a similar fashion, you can see that applying a Gaussian over the red, green, and blue channels respectively gives you a different image. In this case, the Gaussian smooths the image, makes the image a little blurry. It's hard to see with this small display, but you can see that in this case, it maintains the values of each channel and it just smooths the image. The emboss filter, just for completeness. Now, which filter is better for the use case? That is difficult to say, and that is at the core question of convolutional neural networks, where the kernels that we manually inserted here will be the weights, the parameters that the neural network will learn during training, during the forward pass and backward pass. In our case, we are not training, we're performing inference or detection. So we will load the weights that the neural network learned, in our case, for YOLOv5L. But to this day, these common filters are still used for image filtering. So let's jump to the next section here, event size filter.